Welcome to the latest office hours from Bic Gardner. My name is John Kowalski. I'm part of the marketing team here at Bic Gardner, and today we're talking about physical and field testing. If you're unfamiliar with our office hours format, we'll begin with a shortened presentation, usually 20-25 minutes, followed by open discussion. Whatever's on your mind, however we can help, we'd be happy to. So if you have questions, comments, any challenges going on in your own facilities, please log them in the chat box in the bottom right-hand corner of your screen, and we'll get to them in order. Also, we are recording this, and immediately following the presentation, you'll receive an automated email that will have a link to this recording, and we're also recording the discussion. So feel free to share that with colleagues, view it later, or whatever you'd like. So with that, let me introduce our speaker today and resident color expert, Mr. Corey Cohen. He is our Senior Applications Specialist. Corey, sir, it's all yours.
So today's topic is a pretty broad one. Physical testing is a whole large category of instrumentation that we make and sell. So rather than trying to go in depth into all of it, I'm just going to kind of present you guys with a buffet of physical test instruments and just briefly talk about the purpose of each. And then we'll let you lead the discussion, which is kind of the purpose of our office hours format. So if you have any questions on any of this stuff, or if you just want to know more about kind of the principle behind these things, I have my grab bag of various presentations I can open up, and we can go into any topic that you guys want. So let's see what we're dealing with. Fineness of grind gauges. So this is when you have a dispersion of pigments or any sort of solid matter into a liquid or a solution, and you want to know what the particle size is of the dispersed particles. And so the way this works is you have this. This is called. Let me activate my pointer. This here is called a Hegman gauge, or a fineness of grind gauge, or sometimes just a grind gauge. And so you have this canal in the middle of it. And you can see from this side view here that the depth of this canal is going to change as you progress through the gauge. And so what you do is at the deepest part of it, which is up here, you put a little dollop of your material, your paint or coating or whatever it is you're dealing with, and you have this scraper that has a very, very flat edge. And so you scrape that coating along this canal. As it gets thinner and thinner, what's going to happen is once you reach the largest particles in that coating, it's going to start sort of dragging on the material. And you can see here how once you reach like this point here, the largest particles in here are going to start dragging, and you can kind of see where those lines are. And then you can see where the largest particles in your coating is according to the scale that you have here on the side, which often comes in either Hegmans or microns, or sometimes both. Mils too, I believe. We have gauges that are in mils as well. Next up, we have density cups. So this is if you want to measure the density of your liquid in either grams per centimeter cubed or pounds per gallon. These are sometimes just called pounds per gallon cups. And so this is for the purpose of sometimes if you want to weigh out things or measure things by volume, it's often more precise to know the density of your material and then measure it out by weight instead. And so it can be very difficult to ascertain the exact density of a material because in order to do that, you have to weigh the material. You have to weigh a precise volume of the material. And the problem is that it's very, very difficult to get a precise volume. And the reason for that, you can see here, this is a glass full of just water, and you can see This is where the lip of the glass is, and yet the water is stretching up and over in this little bubble, and that's called the meniscus. And this happens with pretty much any liquid because of the cohesive properties of the liquid. It's going to form that little bubble that reaches over it. And so even if you have like a measuring cup with a precise volume, if you fill that with your liquid, you're not going to get a precise volume. You're usually going to get a little extra because of the meniscus. So we have these density cups that have these tops in them. And so what you do is you fill this cup, or you overfill it a little bit, and then put this top on it. And the top has a hole in the center of it that allows the excess liquid to leak out the top as you press it into the liquid. And then you wipe off that excess, and what you're left with is a precise volume of your material, which can then be weighed and converted into a density. Abrasion testing. So our instrument for this is called the Gardner Scrub, and it's a machine that is designed to test the abrasion or the scrub resistant properties of a material or a coating. So if you have a paint and you want to know, how washable it is, how many times you can wipe it with a brush or a sponge before it's going to wear off, or if maybe you're just worried about, a car coating, and that coating is going to be, brushed by people's jeans as they walk by or what have you. So you apply your coating to a panel. This black panel here is what we call a scrub panel. Put it in this machine along with a brush or a sponge or whatever you want to use. There are different materials for different standard test methods. And this carriage here is going to move that brush back and forth along your coating or material a specified number of times until you get a failure. And there are different ways to measure either the failure of a material, or you can set it to a certain number of cycles and do a pass-fail sort of thing. So a number of different ways to use this machine. But again, this is the Gardner Scrub, and it is meant to test the abrasion resistance of your material. These are wet film thickness gauges. So if you want to test how thick your wet coating is, these are two options we have available for that. Here to the right, these are called comb gauges, and these have different teeth with gaps in them that you can press into the material to measure how deep the coating is by which gap is being touched by the material at its highest depth. And then this is called an interchemical gauge, or IC gauge, and it has a wheel with a little canal running through the center of it. And again, as with the grind gauge, that canal is going to vary in depth. And so you just run this wheel along your wet coating, and then the point at which the bottom part of that canal makes contact with the coating is where you measure your wet film thickness. This is another film thickness gauge, but this is a dry film thickness gauge. So the last two things we looked at, those are only for measuring wet coatings before they've been cured. This is for measuring dry coatings, and it is a destructive film thickness measurement because you're actually cutting through. It's a V-shaped blade of a specified angle, and you're using that to actually cut through your coating. And directly looking at the width of that, each layer of your coating, and you can measure that width and convert that into a film depth or a film thickness. The advantage of this type of film thickness measurement is it will work on pretty much any material. You don't have to have a specific type of substrate in order to use this, and you can also use it to measure multiple layers, and you're just directly looking at them. So there's no complicated measurement principle here. It's sort of a direct measurement of the film thickness. Of course, the detriment of this type of measurement is that it is destructive. You have to cut a big gouge in your coating in order to measure it. So it's not typically something you want to use on a finished product. And that brings us to our non-destructive dry film thickness gauges. We have two models. This is the biko test, the full-featured model, which measures film thickness non-destructively. So it uses a magnetic or an electric measurement principle that can measure your film thickness without having to, cut a gouge in it, which is convenient. It works on both ferrous and non-ferrous substrates, meaning it can measure film thickness over iron, steel, aluminum, nickel, what have you. But of course, with this one, you do have to have a metal substrate. This will only work on metal substrate. So this is the full featured one. Again, ferrous and non-ferrous. It has a temperature and humidity measurement as well as a few other nifty features. And then we have the biko test light, which also measures on both ferrous and non-ferrous substrates with the same great precision and accuracy as the biko test full-featured model, but not quite as many bells and whistles as that model. Okay, next up, we have viscosity measurement. There are a few ways you can do viscosity measurement. These are called flow cups. It's a pretty, I would call it a quick and dirty measurement where you fill a cup with your liquid, and there's a hole at the bottom that your liquid is going to run out, and you just measure how long it takes for that liquid to run out the bottom. And the longer it takes, typically the more viscous your material is. And so you can measure that amount of time in seconds, and there's a conversion for each cup to convert that into centistokes. So this is actually measuring kinematic viscosity, it's called, which has to do with the density of the liquid. So there are kind of two categories of these flow cups, and those are, well, the flow cups here at the top, these are referred to as flow cups, and these are a little bit more precise. These ones with the handles, these are called dip cups, and these are a little bit less precise, but a little easier to, a little quicker and easier to perform these measurements. You just kind of dip it in your liquid and lift it up and start the timer. And then we have rotational viscometers, which are a little more full-featured, a little more precise. And we have a few different models here. The one on the left, this is referred to as just a typical rotational viscometer. The one in the middle here, this is a cap viscometer, a cone and plate viscometer, which is good for high shear applications, as well as applications where you want to use a small sample size, because it only takes a few drops of your sample in order to measure with the cone and plate. This one is called the bikovisc DS model. This is what's referred to as a Stormer or a Krebs viscometer. This is pretty much exclusively for architectural paint. And it's a little bit simpler and easier to use than a full-featured rotational viscometer. And I'd be remiss if I didn't point out that we have a new line of viscometers coming out. It's called the bikovisc RT. We have two new models, a full-featured version and a light version. They both have a 5-inch color touchscreen display, 3 available ranges, low, regular, and high for different viscosity levels. They arrive to you, the customer, fully assembled, so pretty much ready to use right out of the box. It has an easy icon-driven menu similar to some of our other instruments. If you're familiar with our Spectro 2 instruments or our new line of wave scan instruments, it's a really easy icon-driven menu, similar to a cell phone. Performance is equal to or better than Brookfield, and it is compatible with all ASTM and ISO methods that call for a Brookfield. We also offer this protective coatings field test kit for those of you who are out in the field testing coatings or testing substrates before those coatings are applied. So this includes a thermo anemometer, a moisture meter, a dry film thickness gauge, and an infrared thermometer. So this is a moisture meter. These are used to verify the moisture content of substrate to determine readiness for coating. It determines correct drying or curing of raw materials. Works with most building materials such as wood, plaster, masonry, gypsum, and concrete. It has a backlit display for easy reading under poor lighting conditions. And it has built-in electrode pins, which are replaceable because if you frequently stick those pins in the concrete, they're going to wear down a little bit, so they are replaceable. And it also does air temperature measurement, which is, of course, an important aspect when preparing to coat a surface. This is our thermo anemometer. So this measures air temperature, air velocity, and relative humidity, all important variables, again, when preparing to coat a substrate. It helps to determine if the ambient conditions are right for painting. It calculates the dew point temperature, which is, of course, important because you don't want dew forming on your coating before it's fully cured. And it is made of impact resistant materials. So you can go ahead and hit it with a hammer. And then you can come back to us and buy another one because you shouldn't hit it with a hammer. It will break. Because it's impact resistant, not impact proof. Don't hit the hammer. Then we have our T200 infrared thermometer. This measures the temperature of the surface to be coated. It has laser targeting to show the precise location of the temperature measurement. Also, you can point it at airplanes and blind some airline pilots or something. It has max min recording, over range indicator, user selectable degrees Celsius or Fahrenheit. Also drop resistant construction. Again, don't hit it with hammers. I don't recommend that. Also, don't point lasers at airplanes. That's not actually recommended. Yeah, don't sue us, please. This presentation is for entertainment purposes only. Don't take me seriously, please. Okay, that is all I have prepared for you. Please ask me questions and I will decide if I feel like answering.
You're in one of those moods today, Corey. It's kind of funny.
If we get sued, I'm just going to throw you under the bus, Kowalski. So, yeah.
Nice. All right. Like Corey said, if you have questions, the jokes are extra, I guess, today, or included, I should say. But if you have any questions, log them in the chat box and we'll get right to them. Whether it's physical testing, field testing, or, if you want to venture in the realm of color and appearance too. Corey is the resident expert there as well. So our first question, Corey, from Jeremy. Where do you take your measurements on the Hegman grind? Right when the paint starts to thin or fade out, or at a later point?
Right when you see, let's go back to that slide. Generally, it's right when you see that first kind of scratch in the coating, right at that starting point. That's where you would typically do that. And typically, you're going to do this a few times and kind of average it to get a sort of more accurate reading.
Okay, good. Another question here. Do we have a PFUN cryptography machine?
I believe that is a fund cryptometer that you're referring to.
Yes.
I believe our sister company Guardco does carry that device.
I'm
Yes.
looking right now here. Let's see. Yeah, I can't find one on their website. Oh, they have something. Let me try and look here. But also check out guardco.com. You might be able to find that faster than I. I'll put it in the box here, the chat box. Other questions? Comes in the chat box here. Other questions that you guys have when dealing with field or physical testing? as Corey mentioned, we have a new line of viscometers. We just launched those about 30 days ago or so. And I think we're starting to ship those shortly too. Other questions, Corey, that you get periodically or frequently when it comes to physical testing?
That's a pretty broad category, as
I know.
mentioned. Let me pick something at random here. So abrasion testing often, so there are standard test methods that call for particular types of brushes. Some call for nylon brushes, some call for hog bristle brushes. We do offer all of the standard brushes needed for those standard test methods. We offer sponges and sponge holders for test methods that call for that. But we also have a holder. It's referred to as I think the sandpaper holder. So you can attach sandpaper to it. I guess there's probably some standard test method that calls for that, but there's also often a request to use a particular custom material that's maybe not standardized. I remember testing some samples a while back that wanted to use just like a rag. And yeah, pretty much any flat material, rag-like or paper-like material can be attached to that sandpaper holder. So it is a pretty versatile machine for testing abrasion or scrub resistance.
Yeah. And I know from doing these webinars and being around color, one of the big things is just standardizing on your process, how you do it, and make sure you do it the same way every single time. So you're comparing apples to apples with results, and from operator to operator and shift to shift.
Very true.
Okay. Other questions, quiet group. And I did put that cryptography device. I just look at our sister company, Guardco.com, and I put the link in the chat. You can take a look there. So other questions? What types of things are you guys measuring out in the field or in the lab when it comes to physical testing? Sorry. He wants to know what is the use of a cryptography machine.
I believe, and I'm searching right now just to make sure I'm not mistaken on this. I believe what it does is it allows you to form a wedge of your wet coating. So like a gradient of different thicknesses across this device that has like a white and black section, and you can move that up and down to determine at which thickness opacity is achieved. So you kind of move this white or black, I'm not sure exactly how it works, but you move one of the sections back and forth until you can no longer see it moving behind the coating, and that's the point where it's thick enough to achieve opacity. So if you're trying to determine where the opacity point is for your coating, that would be the instrument for the job.
Okay, good. Thank you, Corey. I hope that helped out there. What else can we assist with? Like I said, you'll get a recording of this from an automated marketing message immediately following this presentation. Feel free to take a look. If you have any questions after the fact, later this week, next week, feel free to hit reply to that message. It'll come to the marketing team here, and we'll route it to Corey or one of the technical experts. But what else? Do you run into, one of the products I really like is the field test kit. It really provides you with everything you need out there in the field when you're getting ready to, apply that coating. So just one of my personal favorites. What's your personal favorite, Corey? What do you like?
My personal favorite physical test instrument.
Exactly, and why?
Let's see. I would say the most expensive one we sell, but then I don't get commission, so it's not that one. Our biko test instruments are pretty
Yeah.
pretty solid, and despite how functional they are and how long they're known to last, they are very price competitive. Those designed by our, of course, in-house development engineer Rick Trawick. So pretty, I'll go with any equipment designed by Rick. Rick makes good stuff.
Yeah, he does. Good.
Um, Also, our new, of course, the new line of viscometers, of course, designed by Rick as part of a team effort. I'm sure he'd be the first to say that it was not a solo effort, but the bikovisc Rick Trawick, as it were, is exciting because it's the first time we've actually designed and built our own viscometers, actually here in the U.S. These are not built in Germany, as with many of our instruments. These are actually built here by us, Vic Gardner, at our North American headquarters, which is cool.
Yep. Very. Okay, got a couple more questions here. How much accuracy of the paint thickness is measured with non-destructive test method as compared to a micrometer?
Let's see. I can probably look up
Okay.
those values. Let me see.
Yeah, well, Corey's pulling up the specifications here. Keep the questions coming in too. We're getting a couple backed up, which is a good thing. So we have plenty of time to help.
So our listed accuracy is plus or minus 2 microns plus 3% of the measured value. And that is also plus or minus 0.08 mils, again, plus or minus 3% of the measured value. So that's the stated accuracy. It does come with a certificate. Let me make sure I can speak to both versions. I think okay, it's the full version. The Biko Test Lite does not, but the full Biko Test does come with one of our ISO 17025 certificates.
Good. Okay, next question here. We're having issues with powder coat on aluminum extrusions, wide range of texture and gloss. Any suggestions on testing for performance?
So are you looking to test the physical aspects of it or the appearance of this coating?
Ken, if you don't mind, I've allowed you to unmute yourself if you wouldn't mind elaborating. The microphone button's in the upper right-hand corner. It should be in a red circle. If you just click on that, it should open up your microphone on your end. I'll give Ken a minute here.
Or you can type an answer.
Yeah, or you can type an answer if you don't have a microphone. That would be fine too. While he's doing that, next question here from Ashley. Is there any equipment for non-destructive dry film thickness testing on FRP?
What is FRP?
I was just going to ask.
Fiberglass reinforced plastic. I just came up with that off the top of my head. Google was not involved.
Nice.
So there is an option for non-destructive testing on non-metal substrates. That is a Defelsco product that we carry called the Positector 200. So it uses a sonic measurement principle. It sends sound waves into the surface and measures the reflection in order to determine the coating thickness, which is pretty cool. It's kind of like sonar. And one of the benefits of that device is that unlike the typical dry film thickness gauges, it can actually differentiate multiple layers, up to 3 layers, which is pretty cool. So that I can't say for certain whether it would work with your particular substrate and coating, but typically when a customer is interested in that, I like to test some samples. So if you have any ability to send me some samples for testing, please reach out and we can go from there.
Yeah. Does that work, Ashley? In our sister company that carries that Positector, I put their website. It's guardco.com. Just do a search there, or you see Corey's email address on the screen, or you can reply to any of the marketing messages, and we'll get you hooked up. Ken, are you there? Back to you, sir.
Can you hear me now?
We can hear you. Welcome.
Okay. Good to be there.
Good.
So ours is more really appearance. We just get a wide variation in colors and gloss, and the companies come back to us and say, well, it's just paint matches. So we've tried to measure it with gloss, but we still get a wide range of variation in colors, and so just kind of needing some help with that.
Yeah, so the gloss and texture can definitely have an effect on how we see the color. And so this is what 45-0 instruments are good for, because sphere instruments just measure the pigmentation. So if you're seeing something different because of that gloss or texture, the sphere spectrophotometer will ignore it, whereas the 45-0 measures color as we see it. So if you want to include any surface effects and make sure that the actual appearance of the surface is the same as what you're actually seeing, or you're measuring the same as what you're seeing, I should say, a 45-0 instrument is recommended for that. And if you want to go even further than that, if you are having trouble with texture, if different textures are causing different appearance on the surface, we do have a device called the Spectro 2 Profiler, which measures 45-0 color, gloss, as well as surface texture. It quantifies various aspects of the texture of the surface. It can be used to test and QC the actual structure, the actual texture of your surface, and make sure that it's consistent across different batches. So that's a bit of a complex topic, and I don't want to go too deep into that now, but if you want to learn more about our Spectra 2 Profiler, reach out to me and I can talk with you, or possibly point you to one of our other web seminars where we discussed in length the S2P.
Yeah. Yeah, we can also have the sales rep in your area. We'll have them reach out and get in contact with you, and they can run through a full demo of both instruments and really look at your color program and see what they recommend, if that works for you.
I like that better. That's less work for me.
That work, Ken?
Yes.
Cool. All right. We'll be in touch. Thank you, sir. Next question here. Let's see. We do paint coating on steel and aluminum. Can we use both, or can we use the BIC non-destructive coating thickness measurement for both substrates?
Yep. It comes with the ability to, it is a different measurement principle for steel versus aluminum, but it does come with both built in, and it will automatically switch back and forth. It'll automatically detect which substrate you're using and switch the appropriate principle. So yeah, the biko test and the biko test Lite will work for both of those substrates.
Great. Thanks, Corey. Other questions here? We still have a lot of time left. If there's anything we can help, or if you need a demo of an instrument, we can hook you up with that, or just some challenges that you may be having. Anybody? Oh, thanks, Ashley. Another question here. Question about color measurements. Should all D8 spectrophotometers measure relatively the same LAB values, or will it vary from device to device, even if it's the same geometry?
That's a tricky question. They are going to vary a bit from model to model, usually by up to a unit or two. It is recommended that if you're using different models of spectrophotometer, even if they're all D8 models, we do recommend measuring your standards individually with each instrument rather than trying to use one instrument to measure the standard and then just having the absolute LAB values as your target. It works a lot better if you measure the standard with each instrument and then measure the sample with each instrument against that standard, and then the difference values you'll see across different instruments should be fairly similar, even if the absolute values are not.
Did that help, Ashley? Or just write in your chat if you want me to unmute you too, if you have some follow-up questions. Another question came in here. Which color measurements are accurate, LAB model or LCH?
The difference really isn't about accuracy. It's just about mostly it has to do with tolerancing. So LAB and LCH, those are two different coordinate systems for the same color space. So it's all CLAB color space, but the LAB coordinates are rectangular coordinates and the LCH ones are polar coordinates. So it's kind of a different here. I can just pull something up.
Out of your bag of tricks there.
Bag of tricks. Okay. All right. Share screen. There we go. All right. So LAB, you have orthogonal axes, which mean perpendicular to each other. So L is the vertical, A and then B. And so L is for lightness, A is for green to red, B is for blue to yellow. And then you have LCH, which the L is the same. That's still the vertical axis, but rather than having A and B, you have C, which is chroma. So that tells you how saturated or brilliant, or there are a number of different descriptors you could use, but basically how colorful your color is. So like a perfectly neutral color, a white or black or gray, would have zero chroma. A very chromatic color would be like a lime green or a scarlet red, something like that. So that would have a very high C value. So the here where the neutral colors are, the higher the C value, the more you're going out towards the edge of the color wheel. And an H is the hue angle, which describes the actual hue of the color, red, yellow, green, blue, or somewhere in between. And so the positive A axis is 0 degrees hue angle, and then you go counterclockwise from there. So positive B is 90 degrees, 180 is green, 270 is blue, and then back to 360 or 0. And so here, for example, the hue angle is 38 degrees, which is right between red and yellow. So that's an orange color. So it's the same colors. You could describe this same exact color using LAB values. It's just a different way to describe those colors. And the difference, the reason you would use one over another generally has to do with tolerancing. In general, we recommend using LAB for achromatic colors or near neutral colors that don't have very much chroma. Once you get into more chromatic colors, which I think we define that. There we go. This is the general recommendation. If the chroma is less than 10, we say use LAB for tolerancing. If the chroma is greater than 10, use LCH for tolerancing. And I won't go into all the reasons why, but we actually did this exact presentation I did last week, and that recording is still up on our website. So John, if you wouldn't mind grabbing the link for that, you guys can still access that recording for another few weeks if you want to check out our website and view that presentation that goes into why you would use one over the other.
Let me look at that. I can get that right now. Yeah, I'll find it. Okay. Other questions? Regarding color, appearance, physical test? How can we assist? I'm getting that link right now too.
I have some Yo Mama jokes if you guys want to hear. Those have been popular in the past.
Yeah, no. Okay, let's see. Playlists, webinar archives. We also archive all of our webinars on YouTube. So I will post that link for you. I'll do that. There it is. Okay, YouTube. There. You can take a look there. There's a playlist of quite a lot of things, including what Corey just mentioned regarding, where is it? It's there somewhere. Theory and different models, color models. So take a look at that YouTube link. Also, if you have any questions, feel free to hit reply to any of the marketing emails you get, and we'll get them to Corey or someone on our technical team. Questions? Any last questions here? We got a few minutes yet. That might be it, Mr. Corey. Okay. Well, last one. Oh, when will BIC declare the survey winner? Oh, the color your world. That is, people can still vote, I think, till the end of June. So there's time to get that in. Let me put that up here as well. Let's see here. What we did, we put a promotional video out. Oh, I think it was in April. There it is. Well, color changes everything, and it gives kids 16 and under the opportunity to win an iPad. So let me put that link in here. There you go. If you want to check out the video. We've had some good responses there, but still time to enter and get your kids signed up, or your neighbors, or school, classrooms, churches. I think a lot of people are out there still creating their submissions. So that should be wrapping up the end of next month. So thanks for asking about that, sir. So you can take a look there. And with that, I think we'll wrap this up. Stay tuned for future office hours. We try and run those monthly on a different and varying topic. We also run our 60 minutes webinars throughout, the month. So there's lots of stuff going on, lots of education opportunities. Also, keep in mind the YouTube link too. That's where we house all of our recordings. So take a look there. And as always, thanks for joining us. Hope you learned something. Corey, appreciate your time and expertise as always, sir. And even the jokes today. So, hey, bonus. So thank you, everyone, and have a great rest of your day. Thank you, Corey, also.
Bye, guys.